Imagine looking up and knowing a space rock could change everything. Asteroids, ancient, unpredictable, and sometimes dangerous, race past our planet every day. For about a year, scientists have tracked one particular asteroid, 2024 YR4, watching its path with growing concern. Now, the risk has changed. New calculations show a higher chance it could strike the moon, our closest neighbor, and a vital part of Earth's story. Stay with us as we uncover the science, the suspense, and the real-life drama of watching the skies and what it means for our world. In the quiet afterglow of the holiday season, on December 27, 2024, astronomers spotted something new. A faint speck of light was moving through the cosmos on a path that caught their immediate attention. This was the moment asteroid 2024 YR4 was officially discovered. Early data hinted it might threaten Earth, sending a ripple of concern through the scientific community. Initial observations are limited, so predictions span many possible futures, some uncomfortably close to us. Observatories worldwide piled on more measurements to tighten the orbit. Powerful computers projected the asteroid's journey years into the future. By May 2025, Earth was ruled out, relief. But a new concern emerged. A possible collision with our closest neighbor, the moon. Survey flags a mover, others confirm, then rapid global tracking kicks in. 2024 YR4 encodes when it was found, year, half-month, and discovery order. As observations accumulate, models evolve, from Earth risk to moon risk, reflecting the complex gravity dance of sun, planets, and asteroids. Scientists speak in probabilities because measurements always have some uncertainty. After months of tracking and analysis, the chance that 2024 YR4 will hit the moon is about 4%, specifically a possible impact in December 2032. 4% sounds small, like a slight chance of rain, but in planetary defense, that is serious. It's enough to demand attention and planning. These odds come from complex calculations using all available data. In March 2025, the James Webb Space Telescope added precision, nudging the moon impact probability from about 3.8% to 4.3%. Small data changes can shift predictions, another reason to keep watching. Of course, 4% also means a 96% chance it misses entirely. Still, at 1 in 25, YR4 ranked among the most concerning tracked objects. The space community isn't panicking, it's watching closely, because when the moon is at stake, 4% is too high to ignore. Asteroid 2024 YR4 measures roughly 60 meters across, about the height of a 10-story building, tumbling through space at tremendous speed. Not a global threat, but large enough to be a potential city killer. On March 26, 2025, Webb measured its heat and pinned down its size, with an extraordinary margin of error of about 7 meters. Size determines impact energy, crucial for assessing consequences. Mass is harder. Estimates range from 51 million kilograms to over 711 million. Is it dense metal or a loosely bound rubble pile? That uncertainty hugely affects any plan to move it. A moonstrike would far exceed the energy of the largest human-made explosions, carving a new crater likely several hundred meters across, and producing a bright flash visible from Earth, a rare cosmic spectacle. If 2024 YR4 hits the moon in December 2032, it would be breathtaking and violent. A brilliant flash, an immense release of energy, a fresh crater gouged into the lunar surface. The blast vaporizes rock instantly, lofts fine dust and hurls larger fragments. With no atmosphere and weak gravity, debris spreads far and wide. Some pieces even escape the moon entirely. A cloud of material would fill cislunar space. The impact itself wouldn't directly threaten people on Earth, but its aftermath is the real worry. Concern would shift from the rock to the debris cloud it leaves behind. A vast cloud of lunar ejecta could linger, raising hazards for satellites and astronauts, complicating missions for months to years as the cloud disperses. The biggest consequence isn't the crater, it's the debris. That cloud could intersect the lanes where our satellites live. Communication, GPS, weather, science, space assets power daily life. Models suggest micrometeoroid debris in low Earth orbit could spike up to 1,000 times background levels. Even tiny grains hit like bullets at orbital speeds. That means more outages and potential satellite losses. Astronauts aboard stations would face elevated danger. Shields handle normal micrometeoroids, not a thousand-fold surge. Every mission, Moon or Mars, would need new avoidance plans. Most lunar fragments drawn to Earth would burn up as meteors, though a small risk remains that a larger piece could reach the ground. The main issue is prolonged hazard to orbital assets until the cloud thins. Disruptions could ripple into navigation, calls and transactions. Satellite operators would scramble to dodge debris, working through a challenging period as space gradually clears. Scientists and engineers aren't waiting to see what happens. A NASA-led team has examined options to prevent a lunar strike. The goal? Intercept the asteroid far from Earth and nudge its path. This is called a deflection campaign. Act early, push gently, change destiny. Engineers estimate a launch window between April 2030 and April 2032. That timing offers the best shot at a deep space rendezvous. Preferred method: a kinetic impactor, a fast, heavy spacecraft ramming the asteroid. NASA proved the concept in 2022 with DART. But to size the impact correctly, we must know YR4's mass precisely, and we don't yet. Too small an impact, no effect. Too big, risk redirecting it into new hazards. Until mass is pinned down, designing a kinetic mission remains a challenge. That's why agencies are preparing now, so they're ready if the threat solidifies. With mass uncertain, some scientists consider a more forceful backup: a nuclear standoff detonation, not necessarily shattering the asteroid, detonate near the surface. Heat vaporizes a layer, the ejecta jets off, pushing the asteroid like a rocket. Analyses show a 1 megaton device well within current arsenals could disrupt or deflect YR4 across mass scenarios. Technically robust, especially if time is short. But treaties, ethics, and global consent make it a last resort. A failed attempt could fragment the asteroid, several threats instead of one. Any such mission needs unprecedented international cooperation. This isn't about militarizing space, it's about protecting Earth and its orbital environment. If observations confirm a moon impact and a precise kinetic solution isn't possible, the nuclear option could move from theory to necessity. It would be a stark expression of our ability to shape our cosmic fate. Right now, a 4% impact chance is concerning, but not certain. In 2028, YR4 returns close enough for superb observations. Ground and space telescopes will sharpen its orbit dramatically. That pass will slash uncertainty. Odds drop to zero, or climb towards certainty. It's the turning point in this story. If it's a miss, we breathe easier and stand down. If it's a hit, the clock starts. Missions finalized for the 2030-2032 window. This is preparation, not panic. Methodical science, refined tech, and clear decisions. Whether YR4 ends in a dramatic impact or a quiet flyby, the lesson is clear. We live in a dynamic, active solar system, a cosmic shooting gallery. For the first time, we can see threats coming and act. Each new survey and tracked object strengthens our defense. Space has no borders. Solutions demand global cooperation. Scientists, engineers, and governments working together can safeguard our future. Vigilance is an investment in generations to come. Studying asteroids, developing deflection tech, and constant watch ensure our story continues. Planetary defense is our promise to protect the only home we've ever known.